In this video, we'll go over the practice final review problem. Let's go for the first problem. So the first problem is asking for the greatest common factor of the terms, or GCF. Now the first term is 21 m4 and the second term is 189 m to the 9 power. First, we need to rewrite this term in their prime factorization. Now 21, you can factor that into 7 and 3, and 7 and 3 are all prime number. Okay, m to the 4 you can write as m being multiplied together. That's 4m. And 189 you can rewrite that as 3 times 3 times 3 times 7, and 3 and 7 are all prime number. M to the 9 power, again you have 9m being multiplied together. M and m. Now the greatest common factor is the factor that both of the term have the same factor. So in this case, for the number, we have 7 and 3 here, and we also have 7 and 3. For the letter, we have 4m, and here we have 9m, so there's 4m in common. So therefore 7 times 3 times m times m times m times m is the GCF of these two terms. So the value is 7 times 3 times m times m times m times m. 7 times 3, which is 21, 4m, or m to the 4 power. Or this answer is A. The second problem, again, factor out the greatest common factor, or the GCF. We have 12x to the 8 y9 plus 18x to the 6 power y to the 7 plus 30x to the 4 power y to the 4 power. Now the first term, 12, you can rewrite 12 being 2 multiplied by 2 multiplied by 3, because 2 and 3 are prime number. And then x to the 9, which is 8 of the x being multiplied together, and I cannot write them all here because there are not enough spaces here. Now the second one, we have 18, and this can be rewritten as 3 times 3 times 2, and again 6x to the 6 y to the 7. 30 can be written as 5 times 3 times 2. 5 times 3, 15 times 2 is 30. X to the 4, y to the 4. Now you see here, the first term, we check the number first, 2 and 3. The second term also has 2 and 3. The third term also 2 and 3. So 2 and 3 are a common number. So we have, for the number, we have 2 and 3. But for the letters, the first term has 8x, the second term has 6x and 4. So we pick the one that all of them have together, which is 4 of the x, so x to the 4. For the y, the first term has 9y, the second has 7 and 4. So we pick the one that all of them have, which is 4 of y. Now 3 times 2 is 6, x to the 4, y to the 4. So this is the greatest common factor, but we need to factor out for this expression. So I take 6x 4 y4. The first term, when I take out 6x 4 y4, I have 2 left, and then I have 4x left. I have 5y left because I take out 4. I have 5 left because the total is 9. The second term, when I take out 2 and 3, I have 3 left, and then x, I took out 4, and now I have 2 left. Here I took out y4, I have 3 left. The second one I have 5 as a number, and then x4, y4 I already took them outside here, so only 5 left. So this is the answer, or A. Let's move to problem 3. Factor by grouping. Okay, so I have 10x squared plus 8xy plus 15xy plus 12y squared. So factor by grouping. Usually we pick the one that have a common variable together. So the first two terms we see here, we have x and x, so we can combine them together. The second two terms, we see that they have y and y together, so we can group them together. So we group these two and these two together. Now the first term, I can factor out 2x because 10 and 8 have a common factor of 2, and x squared and x and y have a common factor of x. So when I took out 2x, the first term here, I have 5 left because 5 times 2 give me back 10. Now x, I took out 1, I have 1 left. The second term, I took out 2, I have 4 left. And I took out the x, I have only y left. The same thing to the second term, I can 15 and 12, there's a common factor of 3. And x, y, and y, of course, stays y. Now, I took out 3y, that's 5x left, and then there's 4y left. Again, if you compare these two terms, they have the common factor of 5x plus 4y here and here. Therefore, I can print 5x plus 4y. I can factor this out one more time. If I take this term to the outside, I have 2x left. I have the plus side here. If I took this term outside, I have 3y left. Therefore, the answer is this one, which is B. Number 4. Again, factor by grouping. So I have 27 minus 3y minus 9p plus yp. Now, you see that the p and the p, so these two terms can go together. Actually, because there's a y term here, so the y can go with the y, and 9 can also go with 27. So we can rewrite them. 27, let's go with 9p, and the 3y go with yp here. Now 27 and 9, they have a common factor of 9. So I took out 9, I have 3 left, right? 9 times 3 give me back 27. I took out 9, I have minus p left. Now these last two terms, there's a common factor of y. I took out minus y, I have 3 left because minus y times 3 give me back minus 3y. Now if I took out minus y, I have minus p left because minus y times minus p give me yp. Now these two terms again also give you the common factor of 3 minus p. So I can do that one more time. 3 minus p. If I took out 3 minus p here, the first term I have 9 left. The second term I have minus y left. So this is the final answer, which is A. Okay, let's go to problem 5, the next problem. Factor completely. If the polynomial cannot be factored, write the prime. So question 5, x squared plus 8x minus 33. Again, this is the secondary polynomial with a leading coefficient of 1. So we know that we can use a technique of there are 2x here. We need to find the two number when you multiply them together, you got minus 33, and when you plus them together, you got minus 8. You got 8. So it looks like that minus 3 and 11 should be the case, because minus 3 times 11 is minus 33, and minus 3 plus 11 give you plus 8. So here is 11, here's minus 3, and these two should be the value of this question. And this one is corresponding to choice B, option B. Next question 6, x squared minus x minus 35. Again, we need to factor out these two factor. Find two numbers. When you multiply them, you got 35, but when you add them together, you got minus 1. And it looks like that there are not any of the numbers. That's when you multiply them, you got minus 35, and you add them, you got minus 1, because you cannot factor out this factor. Therefore, this polynomial is the prime. Number 7, factor completely. We have 84 x squared plus 49 xy plus 7 y squared. 84 can be rewritten as 7 times 12 and then x squared. 49 is 7 times 7 and then xy, of course 7 y squared here. It looks like that there's 7 is a common factor, so I took out 7. I have 12 x squared, I have 7 xy, I have y squared. Now this thing inside here, I can factor that into another two factor. There's a 12 x squared, so I can write 3x and 4x, because 3x times 4x give me 12x squared. Now the second term is the y term, because y times y give me back y squared. And you can check this is correct, because 3x times 4x give me 12x squared, and 3x times y give me 3xy, and 4x times y give me 4xy, and 3xy plus 4xy give me back 7xy for the middle term, and the last term y squared. So y and y give me y squared. So this answer is B. Question 8, again, factor out completely. I have 4y squared plus 18y minus 10. Again, 4, 18, and minus 10, there's factor of 2. I can factor out that. I got 9y here, I got minus 5 for the last one. And again, we can factor out this into two other factor. So 2y squared, we can write 2y and y, because 2y and y give me 2y squared. Now the last one is minus 5. So we need to see if we're placing 5 minus 5, so the two number here being multiplied, it must give me minus y, so which is minus 1 and 5. So we need to figure out which one go to here, which one go to here, because the two outside term, when you multiply together, when you add with the two inner term here, you must get 9y for the middle term. Because of this one, I must place 5 here and minus 1 here, because 5 times 2y give me 10y, and y times y give me minus y, and when they adding together, I got back 9y. So this answer is the correct one, which is A. Okay, let's go to the next problem. Question 9. Factor the binomial completely. if it is prime, say so. So I have 49k squared minus 36m squared. So 49k squared, you can rewrite this as 7k squared, the whole thing squared, because 7 squared is 49, k squared is k squared. Now this one also 6m, the whole thing squared, because 6 squared is 36 and then m squared is m squared. And remember, that's the formula, a squared minus b squared equal to a minus b times a plus b. And this thing is a squared, this thing is b squared, so I can rewrite as a minus b. A is 7k, b is 6m, and then multiply by a plus b. A is 7k and b is 6m, and this one is b. Next question 10. Again, factor the binomial completely if it is a prime, say so. So this is 10. 9s squared minus 16t4. Look like we can use a similar problem as the previous problem. 9 we can write as 3s, the whole thing square. This is 4t squared and then the whole thing square. 4 squared 16, t squared is t4. And again, a squared minus b squared equal to a minus b multiplied by a plus b. Now this is a, this is b. So we have a minus b multiplied by a plus b. And this is the final answer, which is b. (11) Solve the equation 3y plus 25 7y plus 18 equals 0. So the only thing that makes this expression to be 0 is either one of these becomes 0. So I have 3y plus 25 equal to 0, or 7y plus 18 becomes 0. This one you can you can solve for y minus 25 on both sides. I have 3y equal minus 25, divide both sides by 3. To solve for y, I have y equal minus 25 over 3. And the second one, I can minus 18 on both sides. I have 7y equal minus 18, divide both sides by 7. I got y equal minus 18 over 7. And this answer, these two answers is the option A. The next question 12. Again, solve the equation x 6x plus 30 equals 0. So the only way that's make this expression to be 0 is either this factor is 0 or this one is 0. So we have x equal to 0 or 6x plus 30 equal to 0. Now you already have the first solution to be 0. Solve for x for the second one. Subtract 30 on both sides. I have 6x equal minus 30. Divide by 6 on both sides. I have x to be minus 5. So minus 5 and 0 are the solution, or the option B. The 13th problem. The question 13, x squared plus 7x plus 6 to be 0. Now you can do this by factoring this one into two factors. Again, x squared, and you have x and x here. So these two numbers, when you multiply them together, you got 6. You add them, you got 7. So which one? It's multiply 6 and 1. 6 and 1, you multiply 6 and 1, you got 6. You add them, you got 7. So there's plus 1, plus 6 here. Now these two factors equal to 0. So this means one of these must be 0, or x plus 1 equal to 0, or x plus 6 equal to 0. This one you minus 1 on both sides. You got x to be minus 1. This one you minus 6 on both sides. You got x to be minus 6. So the solution is minus 1 and minus 6, or the option D. Okay, let's move on to question 14. Solve the word problem. So find the 3 consecutive integers so that the sum of the squares of the smaller 2 is equal to the square of the largest. Now, for the 3 consecutive integers, if I have the first one, I call that to be x. The next consecutive integer should be x plus 1. And the next one should be x plus 2 because x plus 1 give me x plus 2. So I know that's the 3 consecutive integers I got here, x, x plus 1, and x plus 2. But I don't know the x first. I have to solve for that. Now, the condition that they gave us here is that the sum of the square of the smaller 2. These two are the 2 smaller number comparing to the larger one here. So the sum of the square of the 2 smaller, that means this number square plus this number square. So the sum of the 2 smaller, the sum of the square of the 2 smaller number is equal to the square of the larger, or the largest number, equal to the square of this largest number. Now, the remaining task is to solve for x. Okay, so before you can solve for x, you must expand this out. So this is x squared. This one becomes x squared plus 2ab. Remember, a plus b squared give me a squared plus 2ab plus b squared. Now a squared plus 2ab, which is 2x plus 1. This one, x squared plus 2ab, is 4x plus 4. Now, this is a quadratic equation. Let's move all the terms to one side first. X squared, that's 2x squared, plus 2x plus 1. Simplify them first. Now, x squared, you minus x squared here. So minus x squared here, you got x squared. And then you can minus 4x here, minus 4x here, and then minus 4, and then minus 1 here. That's gone, that's gone. So the right side now is 0. The left side, 2x minus 4x, that's minus 2x. And 1 minus 1. It should be, oh, this is 4. So minus 1 minus 4, yes, that's minus 3. So x squared, let me rewrite this, x squared minus 2x minus 3 equal to 0. Now you can solve for x, and this equation you can solve by factoring them again. So the two numbers, when you multiply together, you got minus 3. When you add them, you got minus 2. That must be 1 and 3, minus 3. And the only way that this can happen is either the first one is 0 or the second one is 0. And you can solve x to be minus 1 by subtracting 1 on both sides, and plus 3 on both sides. You got x to be 3. Now, if x is minus 1, then your answer here, you got here x is minus 1. The next one, minus 1 plus 1 is 0. Minus 1 plus 2 is 1. If your x is 3, then you have another second set of solution 3. And the next one, 3 plus 1 is 4. And 3 plus 2 is 5. So this should be option B. Okay, let's do the second one. Again, find the 3 consecutive odd integers so that the sum of all the 3 is 36, less than the product of the smaller 2. Now, this problem is a little bit harder because now the 3 consecutive, but we are looking for the odd integers. Now, the first odd integers can be represented by 2x plus 1, because any number when you multiply by 2 should be an even number. and you plus 1, you got an odd number. So the first odd number starts with 2x plus 1. The second number is 2 more of this, because if this is the odd, if you add 1 more, you got to even. So you add 2 more, you got back to the odd. So the second one is 2x plus 1 plus 2, which is 2x plus 3. Now, this number, you add 2 more, you got another odd number, or 2x plus 5. So again, the job is here is to solve for x. Now the condition give us here is that the sum of all 3, that means we sum of this number together. So we sum that, we add them all together, is 36 less than the product of the smaller 2. So the product of the smaller 2 is the product of these two guys. So I have the product of these two. 36 less than, that means we subtract 36 from the product of these two factors. Now you can solve for x. So let's combine the like term, 2x, 2x, 2x. That's 6x. 3 plus 1 is 4. 4 plus 5 is 9. And again, multiply to the FOIL. So that's 4x squared plus 6x plus 2x and then plus 3 minus 36. Now move all the terms to one side and then leaving the rest to be 0. If you do that, I move subtract 6x, subtract 9 on both sides. I got 0 on this side. So let's rewrite this 4x squared. I have 4x squared. 6x is gone. I have 2x left. Now 3 minus 36 minus 9, that's give me minus 42, and then this side is equal to 0. Before you solve this for x, you can factor out the common factor of 2. So because 4, 2, and 42 has 2 as a common factor. So I have 2x squared. I factor out 2. I have x left. I have 21 left. And now I can the only thing that this equation is true is this thing to be 0, because 2 cannot be 0. So just solve this equation to be 0, so for x, and you can solve this by factoring. So 2x squared, I have 2x here and x, because 2x and x give me 2x squared. Now we need to find a number when you multiply them, you got minus 21, and when you add a 2 inner term, you got 1. It should be, that should be plus 7 and minus 3. So here 7 and minus 3 is minus 21, and when you multiply the two outside number, 2x and minus 3, that's minus 6x, and when you add to the inner term, minus 6x plus 7x give you positive 1x here. That's why I place 7 here and minus 3 here, and this equal to 0. And this term, this equation is true when these two equal to 0. And you can move 7 to the right side, and you can divide by 2 on both sides. You have x to be minus 7 over 2, and this one equal to 0. You can plus 3 on both sides, and that gives you x to be 3. And you know that this answer, we have two different answers, but because we are looking for the odd integers, 7 minus 7 half, this is decimal, so this is not correct. We take x to be 3. So when x is 3, the first term, 3 times 2, 6 plus 1 is 7, and then we add 2 more to that, so 9 here and then 11 here. And this one should be option D. Yes, that's D. That's 15. Okay, let's do the next problem is 16. Now this is also a word problem. The product of two consecutive integers. So now we have two consecutive integers. So the first one, I call that to be x. The second one is x plus 1 because they are next to each other. The product of two consecutive integers is 55. That means, no, the product of two consecutive integers. So the product, that means I take x, I multiply by x plus 1. So the product is 55 more than their sum. That means I take their sum, I sum them, and then 55 more, right? So 5x, that means we are finding for the solution for x. So that's multiply here and here. I got x squared plus x, and combine these two, I got 2x and then plus 56. I move that to the left side, right? I move this to the left side. I got 0 to the right side. I have x squared, x minus 2x, that's minus x minus 56 equal to 0. And you can factor out again x and x, and we can go with 7 and minus 8 because 7 times minus 8, that's minus 56. 7 plus minus 8, that gives you minus 1 here. So that's equal to 0. This means one of these must be 0. Or you minus 7 on both sides. You got minus 7. You plus 8 on both sides. You got x to be 8. So there are two set of solutions. If I take x to be minus 7, then I have minus 7. And then minus 7 plus 1, that's minus 6. If I take 8 to be the solution, I have 8. And then the next one, 8 plus 1, that's 9. So this should be either this or this. Then it should be the option B. Okay, let's move to the next question. Should be 17. Find the numerical value of the rational expression for the given value of x. So 9 minus 8x over 5x, x equal 2. So when I plug in x to be 2, so I have 9, 8 times 2, that's 16. And the 5 times 2 is 10. So I simplify 9 minus 16, that should be minus 7 over 10, or D. 18. Again, do the same thing, but this time I have different expression. 9x plus 6 here, x to be 3. So I have minus 4 times 3 square, I mean cube here, and then 9 times 3 plus 6. Minus 4 times 3, that's minus 12, and then cube. 9 times 3, 27. 27 plus 6, right? And this thing, when you cube, that means minus 12 times minus 12 times minus 12. That's minus, that should be minus 1,728 over, that should be 33. And if you simplify this expression, you got minus, divide this on the top and the bottom by 3. They have a common factor of 3. So on the top you got minus 576, on the bottom you got 11, and this should be the answer D. (19) Write the answer in the lowest term. So 2x squared, or the same thing as simplify this. Now 2, you can divide by 2 on the top, and you can divide 4 by 2 at the bottom, you got 2 left. X squared, you can divide on the top by x squared. So this 3, you divide x squared, you got only 1x left. So that's become 1. So now on the top I have 24, on the bottom I have 2 times x. 24 divided by 2, that gives me 12 on the top, and x. So this answer should be D. So let's go over 20. I have 2z cubed over 3 times 12 over z squared. Again, z, I can take out z squared at the bottom, divide the same z squared. I have z to the first power on the top, and I can divide by 3 at the bottom. 12 divided by 3, that's 4 on the top. So I have now 2z to the first power, and then 4 left. Right? 4 times 2 is 8z, or D. Now 21. Find the LCD, least common denominator of 9 over 20 minus 5 over 6, 4 over 30. Now the denominator are 26 and 30. So 20. So first find their prime factorization. 20 can be rewritten as 5 times 2 times 2, because 5 times 2 is 10, 10 times 2 is 20, and then this is 3 and 2, and this 5 times 3 times 2. So for the least common factor, we find the largest number of occurrence of the factor or the number. Now we have 5, 3, 2. So 5, 3, 2 are the 3 different number we have here. So the first one, there are 2 of 2. The second one, there are 1 of 2. The third number, you have 1 of 2. So we pick the larger. So that means we pick 2 of 2, right? For the list, you pick the larger number of 2. So only 2 here, 2 of 2 here, only 1, so we pick 2 of 2. Now for 3, the first one has no 3. The second one has 1 3. The third one has 1 3, so we pick 1 of 3. And again for 5, there's 1 5 here, there's no 5 here, there's 1 5 here. So 1 5 is the largest of 5, number of 5. So we multiply all of them together. 5 times 3 times 2 times 2, that's 60, or D. 22. So again, find the LCD for the fraction. I have 7 over x squared, and I have 9x to the 7. So the denominator is x squared and x to the 7. Which one for LCD, for the list, we pick the larger number of the factors. So the factor 2, x, we have 2, and here we have 7. So which one do I pick? I pick x to the 7, or in this case D. 23. We just want to add or subtract the fraction and then simplify it. So in order to add a subtract fraction, you need to have the same bottom, right? So 5 and 7. Let's find the LCD first, or the least common denominator. 5 and 7. It's look like 35 is the least common denominator. So 5, the LCD is 35. So 5 times what number give you 35? So 5 times 7, right? And multiply 7 on the top too. How about the other one? 7 times 5 give me 35. So the top you also multiply by 5. Now this is 7x 35 plus 9 times 5, that's 45 over 35. Now you can combine them together. 7x plus 45. This looks like none of the answer on the list, but then the answer should be A. And the reason that they have A here, they have all the negative number, is because they multiply the top and the bottom by -1. When you multiply the top and the bottom by -1, you are not changing anything, because the -1 and -1, they cancel each other. So -1 you multiply here to 7x, you got -7x. -1 multiplied to 45 give you -45, and -1 to -35. So that's make your answer look like the one in option A. Sometimes you have to multiply by a -1 to get to the value that they have on the list. So it's a tricky question. 24. Again, add or subtract them. So 2 over r plus 5 over r minus 9. So the least common denominator is r and r minus 9. So r being multiplied by r minus 9. So the first one, I'm missing r minus 9. So I multiply that by the top and the bottom. The second one, I'm only missing r. So I multiply r to the top and the bottom. Now, due to the 2 inside here, I got 2r minus 18 over r minus 9. This one I plus 5r over r minus 9. Now I can combine the top together. 2r minus 18 plus 5r. 2r and 5r give me 7r, and then minus 18 over r minus 9. And this look like answer A is correct. Question 25. Simplify the complex fraction. So complex fraction meaning the two fractions dividing each other. You can turn this into the multiplication by flipping the second fraction. So you turn the division into multiplication, and then you flip the second fraction. So 4 times 5, 20. 7 times 3, 21. So that's D. 26. Again, we are dividing the two fractions together. Now you turn this into the multiplication, and you flip the second fraction. This to the top and this to the bottom. Now, before we multiply them, you can simplify them. y4, y8, so you got 4 left, 7 and 3, so this is gone. 7 minus 3, you got 4 left on the top, so we have x to the 4, and I have 5 y to the 4 at the bottom, or the answer is B. Next problem, 27. Solve the equation. I have x over 4 minus x over 6 equal 9. Now before you can solve them, you need to simplify them. So let's combine these two together. So the LCD of this one, 6 and 4, is look like 12, right? So 4 times 3 is 12. So 3 times x is 3x, and then minus 6 times 2 is 12. So 2 times x is 2x, and this equal to 9 on the right side. Now you can even further simplify this. 3x minus 2x, that gives you only 1x over 12 equal 9. In order to solve for x, multiply 12 on both sides, because 12 is gone here. 12 times 9, that should give me 108, or B is the final answer. Again, we do the same thing for the next question. 15 over x equal to 8 minus 1 over x. So because there's a subtraction on the right side, so we must simplify the right hand side first. So 8 minus 1x, the LCD is x. The first one, there's 1 here, so we multiply by x. So 8 times x, 8x. We already have x here, so minus 1. So the right hand side, you can rewrite this as ax minus 1 over x. Now, for this type problem, we must use something called cross multiplication, right? Because the two fractions are equal to each other. Now, 15 times x, that's 15x, equal to x times ax minus 1. Now solve for x. You can solve for x by simplify this one. So x times ax, that's ax squared. X times 1, that's minus x. Now this looks like we're gonna have the quadratic equation. So ax squared minus 1, bring the minus 15 to the right hand side. So one side should be 0. So I have, this is gone. I have ax squared minus 15 minus 1x minus 15, that's minus 16x to be 0. And this is easy. You can simplify this by factoring out the ax, because ax is the common factor. So I can factor out ax here. I got x left because ax times x, that's give me ax squared, and ax times 2 give me back minus 16x, and this equal to 0. Now this thing equal to 0, that means either ax equal to 0 or x minus 2 equal to 0. And this is, you divide by 8 on both sides, you got x to be 0. One answer here. Or x, you add 2 on both sides here, or x to be 2. So this should be, now because you have to check for the answer before you conclude x equals 0 and x equals 2 are the solution, because we have a fraction here. 0 cannot be the solution, because 0, when you plug in here, 15 divided by 0, dividing by 0, that means undefined. So x equal to 0 cannot be the solution. The only solution here is x to be 2, or C. Okay, let's move on to the next problem. 29. Now the sum of the reciprocal of the two consecutive integers. Again, we have x, two consecutive integers. Now the sum of the reciprocal, that means we take the inverse of these two, we add them together, and this one equal to 19 over 90. And you can simplify this by first combine on the left side using the LCD is x plus 1. X, they are missing x plus 1. Here they are missing the x, and therefore you can simplify this further. On the top it's 2x plus 1, on the bottom is x squared plus 1 when you do the distribution x and x plus 1 here. And this thing equal to 19 over 20, and you can use a cross multiplication techniques. So 2x plus 1 times 20, it should be 90 here. 2x plus 1 multiplied by 90 equal to 19 multiplied by x squared plus 1. Now 90 times 2x, 180x, 90 times 1 is 90, and this is 19x squared and 19. So move everything on one side. So I have 19x squared plus 19 minus 16. No, sorry. So let's move, subtract 180x here and minus 90 on both sides. So this is 0. I have 19x squared minus 161x and minus 90 to be 0. Okay, sorry, here this should be 2x plus 1. I'm missing something here. Okay, here this should be, okay, here x times x is x squared, x times 1, this should be x. So therefore we should have 19x here, and therefore we have this one. Okay, now you need to solve for this equation for x, but because in this problem they give us the solution already, right? They give us the two solutions already. So the first solution must be the x, and the second solution is x plus 1. And solving this can be difficult. How about just plug in the number and see which one gives you the 0. That means that one is the solution to this one. And when I plug in 9 to x here, I got 19 times 9 squared minus 161 9 minus 90, and this is equal to 0. That means 9 is the solution. So I have 9 to be x and 9 plus 1 or 10 to be the second solution, or the answer is C. Okay, let's go to the next problem. We have number 30 here. So 30. Now again we are dealing with two consecutive integers, so we have the x and x plus 1, right? Now this question is they said that the difference of the reciprocal, the difference, that means the subtraction of the reciprocal of the two number equal to 1 over 20. So now combine these two together. The LCD is what? X plus 1. The first one is missing x plus 1. The second one missing x equal to 1 over 20. And on the top you got 1 left. On the bottom you got x squared plus x equal 1 over 20. Now using the cross multiplication, 20 times 1 is 20 equal to 1 times this, or x squared plus x. Now move the 0 to one side. 20 to one side. I have x squared plus x minus 20 to be 0. You can solve this by factoring out the x and x. So minus 5 and minus 4. Minus 5 and plus 4. When you have minus 5 times 4, that's give me minus 20, right? And when you have okay, that should be plus 4 and minus 5, because when you have 5 times minus 4 is minus 20. 5 minus 4 give me 1 here. So this true, only 1x plus 4 equal to 0, x minus 4 equal to 0. And this is true when x equal to minus 5 or x equal to 4. I minus 5 on both sides. I plus 4 on both sides. I got these two numbers. So if I have minus 5 to be x, the next one plus 1 is minus 4. If I use 4, the next one I have is 4 plus 1, which is 5. So either one of these two are correct, and this should be answer A. Okay, let's do the next question. The next one is 31. So find the square root of 49. Should be 7, because 7 times 7 is 49, or B. 32. 5 square root of 625 over 49. Now you can split them first before you can find the square root. So which one, when you square, give you 625, should be 25 because 25 times 25 is 625. Again, 49 we know from here is 7. This is B. 33. Find the radical. Simplify the radical. Now 20, I can rewrite this as what? 5 times 4, right? And 4, I can rewrite this as 5 times 2 square. So because this is square, and this is the square root, the radical, I bring the 2 to the outside. Or C. 34 minus 108. 108. So let's see. 108, I can rewrite 108 as 36 times 3, right? That's 108. Now 36, I can rewrite as what? 6 square times 3, and radical and the 2 they cancel. That means I have a 6 only to the outside. Don't forget the minus here. And this should be C. Okay, let's move on to question this one, 35. So simplify and add or subtract where possible. So 35. So 35, I have 7 radical 5 minus 9 radical 5. Now they have the same radical, so we can combine the number together. 7 and then subtract 9. That gives me minus 2 and radical 5. Right? Or you can think of this as easier way. They have the same factor, radical 5, so I factor 5 out. I mean radical 5 outside. So I took radical 5. I have 7 left here. I have minus 9 left. 7 minus 9 minus 2, the same thing. 36. 4, 18 plus 4, 32. Now 18, I can rewrite this as what? 9 times 2. And this one I can rewrite 16 times 2. Now 9, I can rewrite this as what? 3 square. And 16, I can rewrite as 4 square. 3 square, that's cancel with the radical, so bring 3 to the outside. And 4 again cancel, bring 4 to the outside. 4 times 3, 12. 4 times 4, 16. Now they have the same radical 2. 16 plus 12, that's 28. And that should be A. Next question. Rationalize the denominator and assume that all the variables represent positive real number. Now rationalize the bottom or the denominator. That means we are multiplying that same denominator by the bottom and the top, okay, to get rid of the square. So 50 over x, I can split them up on 50 and x like this, and I multiply the same thing to the bottom up the bottom twice, and do the same thing to the top. Now the two radical, when I multiply, may give me back just one of these, right? Or you can think of x and x is x squared, and this same thing here is radical 50 times radical x, and because square and radical is become x only to the outside. Now 50, I can rewrite this as what? I can rewrite this as 5 square times 2. 5 square 25. 25 times 2 is 50 in radical x, and this gives me what? 5 square. Bring to the outside, I have 5 radical 2, and then x over x, and the two radical I can combine together. 2 times x is 2x over x, or d. Now 37. Now this is 38. 4a over 29. Oh, sorry. 4a over radical of 5. Now, rationalize, that means I multiply the bottom by the same thing to the top and the bottom. Now these two become 5 only, and on the top I have 4a radical 5, or part C. I mean choice C. Okay, the next question, 39. Simplify the radical expression and assume that all the variables represent non-negative real numbers. 5x plus 10, and then 7, and then square. So this looks like that we can apply a plus b square, right, equal to a square plus 2ab plus b square, and this to be a and this to be b. So a square, that means 25x square. 5 square 25, x square is x square, plus 2 times a times b, and plus b square, or this thing square. 10 square is 100. This thing square is, you have left 7. So 25x square, 2 times 5 is 10. 10 times 10 is 100. X, and then radical 7. 100 times 7 is 700. So this should be part D. Now let's do 40. The same thing. We have square root of 3 minus square root of 9, and m minus 3. So just do the FOIL, right? 3 and m, we have 3m, 3 and 3, the two radical we become 3 because of the minus, so we have minus. Now that's a minus, and then 3 and m being multiplied together, minus and minus become plus, and then 9 times and 3, 27. And this thing you can simplify into 9 and 3, and 9 square root of 9 is 3, and then 3 here, square root of 9 again 3, so I can simplify this. So 3m stay the same, right? Minus 3, square root of 9 bring to the outside is 3, m on the inside, and the last one is here, this one, so we just add with this one, and this look like the answer is A. Oh, they do not simplify the 9 to the outside, so therefore you have minus radical 9 here and minus 9m here instead, but it should be A. Okay. Okay, this question is solve the equation. It's 41. So we are given square root of q plus 1 equals 3. So in order to solve for q, I square both sides because I want to get rid of the radical. Now this becomes q plus 1 equal 9. Subtract 1 from both sides. Q equal 8 or A. 42 m plus 3 equals 6. Minus 3 on both sides. I have radical m equal 3. Now I square both sides. M equal 9 or C. The next one is 43. Solve the equation by zero factor property. So x squared plus 2 equal 11. Okay. So you can move the 11 to one side. So x squared 2 minus 11, that's minus 9, equal to 0, right? So this one is what? You can write this as 3 squared, and remember a squared minus b squared equal to a minus b, a plus b. So you can rewrite this as x minus 3 and x plus 3, and this is true only when each of them equal to 0, or x equal 3 and x equal minus 3, and this should be D. Let's go to the next problem. It's 44. Let's solve the equation by completing the square. Okay. Now, in order to completing the square, the first thing is we need to consider the second term. I have minus 12, right? The middle term. I take the coefficient of the middle term, which is minus 12. I divide that by 2, which is minus 6. I square that, which is 36. Now I add 36 to both sides. I add 36 here, add 36 here. Rewrite as a square minus 12a plus 36. 36 minus 27, which is, that should be 9. And this become a, right, plus minus 6, because we take this one, and then square. We take the one with before we square, which is minus 6. So a minus 6, the whole thing square, equal 9. You can solve for this by taking the radical. So a minus 6 equal plus or minus radical of 9. Now plus 6 on both sides. I have a to be radical plus minus radical 9 plus 6. So the first solution is, there are two solutions. Plus radical 9, which is 3. 3 plus 6 is 9. Minus radical 9, which is minus 3, plus 6, that's 3. So that's 9 and 3, or B. The next one is 45. Again, completing the square. Before we complete the square, we need to move this C, the number, to the right side. Now, the middle coefficient is minus 4 divided by 2, which is minus 2. Square that, that's 4. I add 4 to both sides. Now I have x minus 2. Before I square, I have minus 2. So that square equal to 3. 4 minus 1 is 3. Now I take the radical again. Plus or minus radical of 3, and I add 2 on both sides. X equal 2 plus or minus radical 3, and this should be C. The next question. So this one is 46. Now, we are solving the equation using the quadratic formula. B squared minus 22b plus 121. So, equal to 0. First thing, identify A, B, and C. Because the formula has what? Minus b plus or minus b squared minus 4ac over 2a. In this case, a is 1, right? The fun number is in the square term is 1. B is minus 22 and C is 121. So plug in directly to this formula. Minus B, which is minus 22, B squared, which is minus 22 squared, plus minus 4a is 1, C 121 over 2a, or 2 times 1. Minus and minus is 22, plus and minus. There are two solutions, so we have plus and minus. Minus 22 square, that is 481, right? 481, and then 4 times 1 times 121, that is minus 4ac. Okay, let me do it again. 22 minus 22 square, that is 484, and 4 times 1 times 121, that's also 484. 2 times 1 is 2. Now this thing becomes 0, so the radical is gone. I have only 22 divided by 2, or 11. This is simple, so it should be C. The next one is 47. 81k square plus 18k plus 1 equal to 0. So again, we have minus b plus or minus b squared minus 4ac over 2a. A is 81, b 18, c is 1. Minus b is minus 18 plus or minus b squared 18 square minus 4, a 81, c is 1 over 2 times 81. Let's simplify this. Let me simplify the stuff inside the radical. 4 times 81, that should be also should be 0 again on the inside the radical, over 81 times 2, that's 162. So this is gone. We have minus 18 over 162, and let's try to simplify this further. I can divide both sides, both the top and the bottom, by 18, because they have the common factor of 18. So on the top I have minus 1, on the bottom I have 9, or minus 1, 9, which is B. Okay, the last two questions is about the graph of the quadratic secondary polynomial, or the quadratic equation. So they give the coordinates of the vertex and sketch the graph of the equation. So we need to give the vertex and then we sketch the graph. 48. Y equal x squared minus 4. Now, the vertex, what's the formula of the vertex? Okay, remember, we have the formula of what? We have y minus k equal x minus h square. So this one is the formula. Sorry, this should be this should be plus. So x, or you can let's see. No, sorry. The k should, okay, let me rewrite this here, easier to see. Now y equal x minus h square plus k should be this one. Okay, so the formula, the standard equation of the quadratic equation is y equal x plus h square and plus k, and the vertex for this type of equation is h and k, right? So comparing to this equation, now the square term, we have only x, that means the h is 0, right? Now the k is whatever the number here we have, which is minus 4. So therefore the vertex is h is 0 and minus 4 for k. So if you sketch that, you got the vertex is 0 for x and minus 4 for y. So the vertex is here, and because the coefficient of the x squared term is 1 or positive, so your parabola is open up, and the only open up parabola that has the vertex of at this point 0 and minus 4 is the graph of D only. Okay, let's do the same thing to the last question, and this should make more sense. Y equal x plus 4 and square. Again, the standard equation is what? Y equal x minus h square plus k, and the vertex is hk, right? Now the x squared term here, we have 4. You can rewrite this as what? X minus of minus square plus 0. Now because there are 2 minus become plus here, so you're not changing anything, and there's no number here, that means plus with 0. And you can see minus 4 is corresponding to h, k is 0. So you have minus 4 and 0 for the vertex. So minus 4 for x, go 4 to the left, and then go up by 0 because y is 0, so which is here. Now the x term, the x here, when you expand this out, you got x squared plus 2 times, oh actually no, let's not do this way, because there's not a negative in the front of this equation. Therefore your parabola is opened up again. If there's a minus in the front here, your parabola should open down from here, but because we have a positive value here, you should have something open up at this vertex. And the only one that has the graph of the vertex with the open up parabola here is graph A. So that should be the end of your review question for the final practice.